Let's do a couple syntheses here. So in the first one, we'll see that we have a small molecule and we have a keto group over here and we have a double bond, okay, over here. The other thing to note here is that we don't have any additional carbons. So 1, 2, 3, 4, 1, 2, 3, 4. So we haven't added any carbons, right? The methyl group is still there. So all of that is there. The only thing that has changed is the functional group. All right. So let's go ahead and see how we can convert one functional group into another. So this is a ketone, of course, and then we're going into an alkene. Now we have to think about how we can make alkenes, and usually the way you make an alkene is through E1 or E2 mechanisms. So either you can take your ketone and convert it into an alkyl halide, because E2 generally is alkyl halide. Okay, E1 generally you can do with alcohols, all right? So which means that since this is an alcohol chapter that we've just done, we might as well, focus on alcohols, okay? So you can do an E1 elimination using alcohols. So which means that if there was an alcohol present, then we can do dehydration. So, and we know how to convert an alcohol from a ketone. So here, this is what we can do is we can get this and then we can get our alkene. So this is really a very small kind of a synthesis, not that huge. So to go from a ketone to an alcohol is actually a reduction. So if you do a reduction, what kind of reagent do you want to use? Since this is a ketone and you're making a secondary alcohol, you can either use sodium borohydride or you can use LaH, lithium aluminum hydride. Both of them you can use. Now, when you write these syntheses for me, you can say, you know, one is this and then two would be the H3O plus. And remember, the acidic wash is to make sure that you protonate your alcohol. If you forget to write the H3O plus, it's fine. It's okay. All right, we'll survive. So ketone to alcohol is a reduction, and then from alcohol to that alkene, this is going to be now H2SO4. Now I want to point out one more thing here. H2SO4 is the the concentrated H2SO4, so a nice dehydrating agent. I want to mention just one more thing here is that if you look at this alkene, this is a Zaitsev alkene. Zaitsev meaning the more stable, okay, alkene that we have here. So I think I misspelled Zaitsev here, so Zaitsevs. But in any case, so it's a more stable alkene. So because it's the stable alkene, I can actually go ahead and do the dehydration without any problem. If it was a Hofmann alkene, which is the less stable alkene, I may have to do another step, okay? And if you want, let me go ahead and do that right here with you. And I know you might think it's confusing. Let's not do that, but you know, we'll go ahead and do that anyway. So here is a less stable alkene, you know, very similar to what you have up there. So the Zaitsevs is the more substituted alkene. And if we had to make the green one here, which is the Hofmann alkene, I can still use this alcohol, not a problem, okay? But what I will do now is I will convert it to an alkyl halide. Okay, so now I'll use PBr3 or I can use SOCl2 for, you know, the thionyl chloride and convert it into a halide. So once I have the bromide, now I can use E2 mechanism here. Okay, so the E2 mechanism will mean that I need a bulky base in order to do this kind of elimination to give me Hofmann. So bulky base E2 eliminations, they give you the Hofmann alkene, and then alcohol dehydrations, those will give you the more substituted alcohols. With H2SO4, this is more like an E1 mechanism, carbocation mechanism, okay? The E2 does not involve carbocation. Okay, so that was the first synthesis. Now let's look at the second one. The second one is where the alcohol is just gone. Okay, vamos, that's gone. So we have to get rid of it, which means that the best way to do this is to dehydrate the alcohol and then go ahead and do hydrogenation. Okay, so we'll go ahead and dehydrate the alcohol. Now remember, when you dehydrate, make sure you make the more stable alkene. Okay, for H2SO4, you will always make the Zaitsev's product. I look for those things, okay, because eventually it will give you the same product. So you do the hydrogenation right now, H2 with the palladium or platinum. So if you do hydrogenation on this alkene or this alkene, you will still get butane. That's not a problem. But the thing is that this product should also be correct. Okay, so don't give me this product. Make sure you write the one that is appropriate. Okay, so these are these two small syntheses. Not exactly big time multi-step. Okay, but still good.